Hello everyone. In this video, we'll discuss about the mesh analysis with dependent sources. Okay, we have four different dependent sources. One is the voltage dependent voltage source, Another one is current dependent voltage source. Okay, these two are voltage sources. So the voltage source can either depend on the voltage or on the current. So this voltage can be across any of the elements and current flowing through any of the elements. Similarly, in the current source also we have two different current sources, dependent current sources. One is the voltage dependent current source, another one is current dependent current source. Okay, so here we have given a voltage dependent voltage source. So this is 10 V0. So this is the voltage source. This depends on the V0 value. V0 is nothing but voltage drop across this particular 10 ohms resistor. Okay. So now we have to find out the value of current flowing through this mesh. So we have only one mesh and we have three sources, two independent sources, that is 6 volts and 10 volts, and one dependent voltage source, that is voltage dependent voltage source 10 volts. So while writing the mesh equation, we have to write the equation by considering this voltage dependent voltage source as the ordinary independent voltage sources. Okay. So after writing the equation, we have to find out the value of V0. Okay. So first we'll write the mesh equation. So for writing the mesh equation, we have to find out the voltage rise as well as the voltage drop. Okay. So the voltage rise is with respect to voltage source only. If the direction of the current is flowing from negative to positive with respect to voltage source, then it is considered as voltage rise. Okay. So if you see here, it is always advisable to assume the current in clockwise direction. Okay. This unknown value is flowing in the clockwise direction. So now with respect to this 10 V0, this current is flowing from positive to negative. So this is considered as voltage drop only. So if you see this 6 volt source, now the current is flowing from negative to positive. So this is considered as voltage rise. Okay, voltage rise is always with respect to voltage source only. That too, the current should flow from negative to positive. So this is voltage rise. So this voltage source value is considered as voltage rise. So next we have one more voltage source, 10 volt source. So with respect to this I is flowing from negative to positive. Okay, this is again voltage rise. So this voltage source is also considered as voltage rise. So voltage rise is equal to 10. So next we have to add these two voltage rises. Now the sum of voltage rise is equal to 10, 6 plus 10, that is equal to 16. So this is equation number 1. So next we have to write down the voltage drops. We have to write down all the voltage drops across the resistors as well as the voltage source. So this 10 V0. So as already discussed, the current is flowing from positive to negative. So this is considered as voltage drop only. So we have to write it as such. Okay, the value is given as 10 into V0. So for time being, we'll write it as 10 V0 only. So next we have to write down the voltage drop across 10 ohms resistor. So the current flowing through this 10 ohms resistor is I. The resistance value is 10. So by Ohm's law, V is equal to I into R. So 10 into I is the voltage drop across 10 ohms resistor. So next we have to write down the voltage drop across 100 ohms resistor. So current flowing through this 100 ohms resistor is I only. So resistance value is 100. So 100 into I. Okay. So we have written all the voltage drops and all the voltage rises. So now we have to add all the voltage drops. Okay. So 10 V0 plus 10 I plus 100 I. Okay. So by adding all these, we'll get 10 V0 plus 110 I. So this is equation number 2. Okay. So now we have written the voltage rise as well as the voltage drop. Okay. So now we have to equate these two for getting the Kirchhoff's voltage law equation. So by Kirchhoff's voltage law, we already know that sum of the voltage rise equal to sum of the voltage drops in a closed circuit. Okay, or sum of the voltage drop equal to sum of the voltage rise. So we can equate these two equations 1 and 2. So 10 V naught plus 110 I equal to 16. So this is equation number 3. Okay. So now our aim is to find out the value of I. So this V naught is given as the voltage drop. Okay, it is given in the problem. So V naught is nothing but the voltage drop across this particular 10 ohms resistor. So we already assumed the I as a current flowing through this 10 ohms resistor. So we can write the V naught as the voltage drop across 10 ohms resistor in terms of I. Okay. So given that V naught is equal to 10 into I. Okay. So V naught is nothing but the voltage drop across 10 ohms resistor. Current flowing through 10 ohms resistor is I and resistance value is 10. So by Ohm's law, V naught is equal to I into R. So 10 into I. So this is equation number 4. So now we can substitute this equation number 4 in equation number 3. So these are the two equations we have obtained. Third equation 10 V naught plus 110 I is equal to 16. And fourth equation V naught is equal to 10 I. Okay. So now we'll substitute fourth equation in third equation. Okay. So now this equation 3 will become 10 into 10I plus 110I equal to 16. Okay. So 10 into 10, 100. So 100I plus 110I equal to 16. So by adding these two, we'll get 210I is equal to 16. Or I is equal to 16 by 210. This will be equal to 0.07619 ampere. Or this can be written as 76.19 milliampere. So next we'll solve the other problem. Find the power supplied by the dependent source for the circuit shown in the figure below. So this is a given circuit. Here again we have one more dependent source over here. So this is again the voltage dependent voltage source only. Okay, 2 V naught. So this V naught value is given as the voltage drop across 1 ohm resistor. Okay, here we have two meshes. So we have to assume two mesh currents I1 and I2. So always assume the mesh currents in the clockwise direction. I1 and I2 are assumed as flowing in the clockwise direction. So if you see mesh 1, here we have one current source on the outer periphery of mesh 1. Okay. So this is considered as super mesh. In that case, we should not write the mesh equation. Instead, we have to equate the branch current to the source current. Okay. This is super mesh 1. Okay. Mesh 1 is considered as super mesh. So the current flowing, suppose this branch is considered as AB, the current flowing through this particular branch, okay, is I1. Okay, I1 is the current flowing through this particular branch. Whereas this I1 is flowing from A to B and the 1 ampere source is flowing from B to A. Both these are in the opposite directions. So we have to write I1 is equal to minus 1. So this is equation number 1. So next we have to write the equation, KVL equation for mesh 2. Okay. So here we have to write down the voltage rise as well as the voltage drops. So voltage rise is always with respect to voltage source only. Okay. So here we have two voltage sources. One is the 5 volt source, independent source. Another one is 2 into V naught. Okay. This is a dependent voltage source. Okay. So now we have to consider both these voltage sources. So with respect to 5 volt source, the current I2 is flowing from negative to positive. So if the current is flowing from negative to positive, then it is considered as voltage rise. So voltage rise is equal to 5. Okay. So if you see this voltage source, the current I2 is flowing in the downward direction, that is from positive to negative. So it is considered as voltage drop only. So voltage drop 2 into V naught. So next we have to write down the voltage drop across 1 ohm resistor and 2 ohms resistor. So now the voltage drop across 1 ohms resistor is equal to current flowing through this particular 1 ohm resistor into 1. Okay, by Ohm's law V is equal to I into R. So here this 1 ohm resistor is lying in between mesh 1 and mesh 2. So the current flowing through this 1 ohm resistor can be written as either I1 minus I2 or I2 minus I1, because I1 is flowing in the downward direction from mesh 1 through this 1 ohm resistor. I2 is flowing in the upward direction through this 1 ohm resistor. Both these currents are in the opposite directions. So now we are writing for mesh 2. So we have to write it as I2 minus I1 multiplied by 1. So this is equal to minus I1 plus I2. So next we have to write down the voltage drop across 2 ohms resistor. So this 2 ohms resistor is lying in mesh 2 and current flowing through this 2 ohms resistor is I2 only. Okay. So the voltage drop is 2 into I2. So now we have to add all the voltage drops. So sum of all the voltage drops will be equal to 2V0 minus I1 plus I2 plus 2I2. Okay. So on simplification, sum of the voltage drop is equal to minus I1 plus 3I2 plus 2V0. Okay. So now we have to write down the Kirchhoff's voltage law equation. By Kirchhoff's voltage law, sum of the voltage drop is equal to sum of the voltage rise. Okay. So this can be written as minus I1 plus 3I2 plus 2V0 equal to 5. So this is equation number 2. So this is the second equation we have obtained. Minus I1 plus 3I2 plus 2V0 is equal to 5. Okay. So now we have to find out the value of V0. So V0 is given as the voltage drop across this particular 1 ohm resistor. So here it is positive and here it is negative. So in general, the current is always assumed to be flowing from the positive terminal only. Okay. So this is the direction of the current flowing through this particular branch. Suppose this is considered as C and D. Okay. So since the positive terminal is given here, so the current should always be marked as flowing from the positive terminal. Okay. So we already know the current flowing through this particular 1 ohm resistor is I1 minus I2 or I2 minus I1. So now this branch direction is from D to C. So this I2 is also in the same direction, whereas I1 is in the opposite direction. So we have to consider the current flowing through this particular 1 ohm resistor as I2 minus I1. Okay. So this I2 minus I1 multiplied by this 1 ohm gives the V0 value. So V0 is nothing but the voltage drop across 1 ohm resistor. So V0 can be written by using Ohm's law. By Ohm's law, V is equal to I into R. Now the current flowing through 1 ohms resistor is I2 minus I1. So the resistor value is 1. So V0 can be written as minus I1 plus I2. Okay, this is equation number 3. So now we have to substitute this third equation in second equation. So now the second equation will become minus I1 plus 3I2 plus 2 into minus I1 plus I2 equal to 5. So on simplification, we will get minus I1 plus 3I2 minus 2I1 plus 2I2 equal to 5. So this can be written as minus 3I1 plus 5I2 equal to 5. So this is equation number 4. Okay. So already we know that from equation number 1, I1 is equal to minus 1. Okay. So now we can substitute equation 1 in 4. So now we have to substitute equation number 1 in 4. Okay. So the fourth equation will become minus 3 multiplied by minus 1 plus 5I2 equal to 5. So minus 1 into, minus 3 into minus 1 is 3 plus 5I2 equal to 5, or 5I2 is equal to, this 3 will come this side. So 5 minus 3 will be equal to 2. So I2 is equal to 2 by 5. So that is equal to 0.4. Okay. So now our aim is to find out the power supplied by 2 into V0. Okay. So 2 into, already we know that V0 is nothing but I2 minus I1 into 1. Okay, voltage drop across 1 ohm resistor multiplied by current flowing through this particular voltage source is nothing but I2. So this is V0. V0 already we have found out. Okay, V0 is nothing but the voltage drop across 1 ohms resistor. So I2 minus I1 into 1. So now we have to substitute all the current values. I2 value is 0.4 minus of I1 is minus 1. Again I2 is 0.4. So this is equal to 2 into. So if we simplify this, this is 0.4 minus of minus will become plus. So 0.4 plus 1, 1.4 into 0.4. So this will be equal to 1.12 watts. Okay, this is the answer.